So in this video, we are gonna read Rust Lang, the official book that is available on the Rust website, and it's free to read, so you can go ahead and read it yourself. But in this particular video or in the upcoming series, I'll be reading this book and hopefully creating videos for complete book. Now, the reason I have started reading Rust is because recently I got accepted for GitHub externship and I'm working with a project, a blockchain project, right? A Web3. So this is possibly the year when I step into Web3. Well, I have already stepped into, but hopefully by the end of this year, I'll be really good at it, right? That's the New Year resolution that I have taken. I have posted that on my Twitter as well. If you haven't checked out, just go ahead and follow me on Twitter, right? Anyways, coming back to Rust, I've started learning Rust. So I have actually gone through a bit of stuff with Rust, right? But this is officially me starting a book on Rust, which is completely free and you can read it as well. Now, a couple of things about this book. This is beginner friendly book. Anyone can read it. You just need a little bit of programming experience because this book does not start, let's say it doesn't go about the basics of programming. It goes about basics of Rust but not basics of programming. So if you want to start Rust with this book, you need to learn programming and you need to know programming in any one language, right? You just need to know the paradigm of programming. That's all. Apart from that, this book contains 3 projects, right? First one would be programming a guessing game. Second one would be, I guess, somewhere around here, an IO project, input out project, building a command line program. I don't know what that is yet. I mean, the program, right? I don't know what the program is. Anyways, and the final project would be building a multi-threaded web server, which sounds really interesting and I can't wait to reach to that point. So let's just begin. Before starting that, one more thing. I have opened 3 things on my computer right now. First one is the Google Chrome where I am reading the book. Second one is VS Code where I have opened Rust Lang folder where I'll be storing all my code, and the third one is a terminal which also is opened up inside that directory. If that's not visible enough, I'll just make it large. Okay. Now you can also go ahead and set those folders up. We will start reading Rust programming language now. Okay, this chapter does this book doesn't really contain anything. This just tells that in this current edition what changes have been made, what things have been added. So since we haven't read any version before, since I haven't read any version before, I'll just skip ahead and move to the forward. Actually, I'm gonna skip that as well. Let's move to introduction, right? So welcome to the Rust programming language, an introductory book about Rust. The Rust programming language helps you write faster, more reliable software. High level in ergonomics and low level control are often at odds in programming language design. Rust challenges that conflict through balancing powerful technical capacity at great developer experience. Rust gives you an option to control low level details such as memory usage without all the hassles traditionally associated with such control. So this paragraph basically tells us that Rust programming languages is an introductory book about Rust. The Rust programming gives us more developer friendly experience, like great developer experience, powerful technical capacity. So basically the cool thing about Rust is that it not only have the type safety, it also has memory safety, which we will see very soon. But yeah, it does have that. So who is Rust for? It is for students. So if you are a student, you can read. Okay. Yeah, so how to use this book? This book is generally assumed you're reading front to back, so let's do that. And I guess we don't need to read this part. Getting started. Okay, let's start our Rust journey. Okay, there's a lot to learn, but even every journey starts somewhere. In this chapter, we'll focus installing Rust, writing a program, hello world, and using cargo. So I actually have already installed Rust, right? So you can come or just go to Rust and I guess get started, and you should be good to go using Rust up. So Rust up, well, I understand that Rust up is okay, it's written Rust up, the Rust installer and version management tool. So basically we can manage version of Rust with Rust up. So that's the thing. You will install that, and with that you will get cargo, which I probably think we'll get to see this. Okay, so let's see. We are creating hello world, our first program, Rust program, right? Now that you have installed Rust, let's write your first Rust program. It's traditional when learning a new language to write a little program that prints the text hello world to the screen. So we'll do the same here. Note, this book assumes basic familiarity with command line. As I told you, you should at least know a little things about your IDE, your code editor, whichever you're using, and terminal, right? And a little bit of programming. Anyways, so we are simply creating projects. We have created projects. So I'm just gonna say, let's say it's getting started. So chapter 1, right? So I'm just gonna say we'll create CH1 and let's say CH1.1, 1.1. Wait, I have created a file, my bad. I'll create a folder with name CH11. Okay, and inside that I will create a folder. Again, I'm creating a file. I actually don't use this GUI a lot. I mostly create folders from my terminal, so I'm getting confused. Okay, so we will create main.rs, excuse me. RS is the file extension with which we use. My bad. Okay, so to write Rust programs we use .rs files, right? That's what I wanted to tell you. Okay, so we will create fn main, simply main function, and inside that we can simply say println and hello world. Okay, this should work. Actually, we can give a semicolon as well here. Yeah, hello world. So you would think that println exclamation mark is a function, right? But it actually is not a function. It's a macro, right? So everything you'll see ending with a exclamation mark is a macro in Rust. So what are macro? I guess we will see somewhere down the road in this book, but for now let's just say these are functions, right? Let's just say these are functions for now, but it is not, right? Okay, so anatomy of a Rust program we'll see, but first let's compile using Rust C. Rust C is the compiler that we'll use. We'll pass the main.rs and we'll have .main in our yeah. Okay, so what I can do, I can simply open terminal here, right? But since I have told you that I have already opened my terminal, so I'll just simply go to CH1 and hello world, and here I should have my main.rs. So what I'll do, I'll just say rust c main.rs, and that should compile and give me a main executable main. So what I can do, I can simply call this and it should print hello world. So pat your backs, because we have a hello world program written in Rust, right? And we didn't use any boilerplate or something. We created that ourselves, and I can actually go ahead and remove this main. Yeah, and yeah, we are back to main.rs. Now we'll see the anatomy of main Rust program, right? So let's review in details what just happened with your hello world program. Here's the first piece of puzzle. So this is the main function, right? So these lines define the function in Rust. So main is nothing but a function, but main is a special function. We all know, if you have programmed in language such as Java or C++, you would know about main. So main is like an entry point, right? Your complete program starts with main function, and then main function calls the other functions, right? That's what we know if you have programmed in C++ languages, right? These lines define Rust functions in Rust. The main function is special. It is always the first code that runs in every executable program. The first line declares a function named main that has no parenthesis and returns nothing, right? Okay, no parameters. My bad, not parentheses. That's what I was thinking. If there were parameters, they would go inside parentheses. Okay. Also note that the function body is wrapped in curly braces. Rust requires these all around function bodies. It's good style to place the opening bracket on the same line as the function declaration, adding one space in between. Did we do that? We didn't do that. So it's saying that this curly brace will contain the body of the function. This is how we define a function with fn keyword, the name of the function, and parameters we can pass in between these parentheses. I guess I should make it a bit bigger. Is that fine? I guess so. Yeah. Okay. And it's good style to keep the opening braces on the function definition line and give a space here. Okay, cool. So here will be, yeah, adding one space in between. If you want to stick to a standard style across Rust projects, you can use the automatic formatting tool called Rust FMT to format your code in a particular style. Rust team has included this tool with the standard Rust distribution like Rust C, so it should already be installed in your computer. Check online for documentation. Right, so we should have Rust FMT. Let's check that out. So cd ch hello world, and let's see, Rust FMT main.rs. Okay, it formatted. It did something. Let's make it like this and let's format it. Okay, it did format. Great. So we can use Rust FMT like that. First, Rust style is to indent with 4 spaces, not a tab. So this apparently should be spaces, not tab, right? But it's not Python, so it won't give you an error if you use tab either. So if I use tab, I should be able to Rust C main.rs, and yeah, it compiled successfully, right? So second, println calls Rust macro, right? It is called a if it called a function instead, it would be entered as println without the exclamation mark, right? So yeah, we'll discuss Rust macros and details in chapter 19, so brace yourself for that. For now, you just need to know that using a exclamation means you're calling a macro instead of a normal function, and that macros don't always follow the same rules as functions, right? But we'll see them in more details in chapter 19, right? Third, you see the hello world string. We pass this string as an argument to println exclamation mark, and the string is printed to the screen. Fourth, we end the line with a semicolon, right? Which indicates that this expression is over and next is ready to begin, right? So basically, like in every other language, semicolon defines the end of that statement, right? Okay. Compiling and running are separate steps, right? So we use Rust C to compile, then we will normally run the program like an executable file, right? So yeah, that's the thing. And this shows the source code
file with executable. If your main.rs was your hello world program, this line should print hello world to your terminal. If you're more familiar with dynamic language such as Ruby, Python or JavaScript, you might not be used to compiling and running program as separate steps. Rust is ahead of time compiled language, meaning you can compile a program and give the executable to someone else and they can run it even without having Rust installed. If you give someone a .rb.py or .js file, they need to have a Ruby, Python or JavaScript implementation installed respectively. But in those languages, you only need one command to compile and run. So everything is a trade-off in language design, right? So you got the point, right? So Rust is ahead of time compiled, so it will generate an executable file. Then you can share it to anyone you like, and they don't need Rust to be installed on their system to run that program, right? But if you give someone a JS file or Python file, .py file, then they would have to have Python interpreter or Node.js installed in the system to run that file. So yeah, we have two different steps to compile and then run in Rust, but it's a trade-off, right? Basically, just compiling with Rust is fine for simple programs, but as our program grows, you want to manage all options and make it easy to share your code. Next, we'll introduce you to Cargo tool, which helps you write real-world programs, right? So that's the thing. Enters Cargo. Let's see. Hello Cargo. Okay, let me zoom in a little bit. Awesome. Yeah, Cargo is Rust's build system and package manager, right? So yeah, Cargo is the package manager. Rustup is a version manager for Rust itself, right? Most Rustaceans, would I be called Rustaceans? Okay. Most Rustaceans use this tool to manage their Rust project because Cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depend on, and building those libraries. This is basically NPM for Rust if you're familiar with Node. We call the libraries that your code needs dependencies. The simplest Rust programs, like the ones we have written so far, don't need any dependency. So if we had built the Hello World project with Cargo, it would only use the part of Cargo that handles building your code. As you write more complex Rust programs, you'll add dependencies. If you start a project using Cargo, adding dependencies will be much easier to do. Okay, so basically Cargo will handle all the package managing, right, and building, optimizing our code, hopefully. Let's see, right? Because the vast majority of Rust projects use Cargo, the rest of this book assumes that you're using Cargo too. Cargo comes installed with Rust if you use the official installer discussed in installation section. If you install Rust through some other means, check whether Cargo is installed by entering Cargo version. Hopefully we have it installed. Let's see, I need to remove that $sign. I don't know why they put a $sign in the copy thing. Anyways, so yeah, we do have Cargo installed 1.58.0, right? It's latest version only, 2022. Okay, let's see. So now we can build new projects using Cargo. So to create new project, we need to run Cargo new, then project name. So let's see, I will go out of chapter 1, I guess, here as well. So I will create mkcdir. Yours should not work like this. Chapter 1, 2. So yours should not work like this. I have wrote a script for this. So this basically will create a directory and cd into it. So this is basically saying like mkdir, then name, I guess 1.12, and then cd into that, ch12. Okay, this is similar to that. mkcdir, I will simply say ch1 2, and I am inside that cd, right? Okay, so inside that I would do cargo new and hello cargo. So I'll say hello cargo new hello cargo. Okay, so created new binary cargo. So let's see, and we should have that in our code as well. Okay, so with cargo we got a couple of things, right? Let's examine that one by one by reading, I guess. Okay, so we have main.rs inside src now, and we got two new files, cargo.toml, which I'm thinking that it's equivalent to package.json. Again, if you are familiar with Node, right? If you're not, this basically will contain the package information that we are using inside our project. That's what I was going for. And .getignore just contains /target for some reason. We don't even have that right now. So let's see if we get okay, so it also has installed a new Git repository along with getignore. Git files won't be generated if you run cargo new within an existing Git repository. So we don't have any existing repository, so we'll just simply say open cargo.toml in your text editor of your choice. It should look similar to listing 1-2. So we have this, right? We have edition 2021, but we have the similar thing, right? And we have dependencies, which is empty for some reason, because we don't have any dependency, right? So yeah, this is a TOML file, Tom's obvious minimal language format, which is cargo's configuration format. So first line package is the section heading that indicates the following statements are configuring a package. As we add more information to this file, we'll add other sections. Next 3 lines set configuration information cargo needs to compile your program, the name, the version, and the edition of Rust to use. We'll talk about the edition key in Appendix E. Okay. The last line dependencies is the start of a section for you to list any of your project's dependencies. As I told you, in Rust, packages of code are referred to as crates. We don't need any other crate for this project, but we will in the first project in chapter 2, right? So we'll use this dependencies section then. Now open src/main.rs and take a look. File name src main.rs. So we have that, I guess. Okay, we have the same thing which we wrote here in this main.rs, right? Okay, cargo has generated hello world program for you, just like the one we wrote in listing 1.1-1. So far, the difference between our previous project and cargo generates are that cargo plays the code in our src directory, and we have a toml file, right, in the top directory. Cargo expects your source file to live inside src directory. The top level project directory is just for readme files, license information, configuration files, and anything else not related to your code. Using cargo helps you organize your projects. There's a place for everything. Everything is in its place, right? If you started a project that doesn't use cargo, as we did in hello world project, you can convert it to a cargo project, move the project source to src directory, create an appropriate cargo.toml file. That should do it. Anyways, let's try and build our cargo project, right? So let's take a look at what's the difference between building and running, right? So basically what I'm given to understand that when we say cargo build, right? Oh, we are in the wrong directory, my bad. cd ch1 2 hello cargo, and yeah, we are in the right directory. Now we can simply call cargo build. Yeah, it should create target file, right? And inside that we have debug, and inside that we have hello cargo file. So I'm understanding that this is the thing that we can run simply. So we can simply do like target, then we'll go into debug, my bad, debug. Let me just get this straight. debug, what the hell, debug, and hello cargo. This should run hello world, that's the thing. But what when we do right, so build command just built the thing and we didn't get the output, right? But when we do cargo, let's say cargo run, it built, right, the things that we get here finished, but it finished in 0.03 seconds because since we had the target already. Let's go ahead and delete this, right, and then run cargo run. So it compiled, it finished, then it started running, right? So cargo run ran executed in 3 steps: compiling, finished, and running. So basically these two are similar steps, right? So it compiled and then ran. Cargo build only compiled, right? So yeah, that's the difference. I'm guessing if all goes well, hello world should be print. Running for the first time causes cargo to create a new file on top level, cargo.log. This file keeps the track of exact versions of dependencies in your project. This project doesn't have dependencies, so file is bit of sparse. You won't ever need to change this file manually. Cargo manages its contents for you. Okay, we just built a project with cargo build and ran it with this, but we can use cargo run to compile the code and then run the resulting executable all in one command. Okay, that we did, right? So okay, if we modify, then it will compile again, else it will just simply run. Okay, so let's so we have actually, if we run again, it will just do this, and if we go ahead and add a couple more exclamation marks and run again, it will compile again, run. Okay, works. Amazing. Now cargo check. Cargo also provides a command called cargo check. This command quickly checks your code, make sure it compiles but doesn't produce an executable. Oh, okay. So cargo check will not produce an executable, but it will compile every time. I mean, check if we have any errors in our program, right? Why would you not want an executable? Often is much faster than cargo build because it skips the process of producing an executable. If you are continually checking your work while writing code using cargo, speed up the process. As such, many Rust stations run cargo check periodically as they write programs to make sure it compiles. They can then they run cargo build when they are ready to use the executable. Let's recap what we have learned so far. We build using cargo build. We build and run the project using cargo run. We build a project without producing a binary using cargo check. Instead of saving the result of build in the same directory as our core code stored in target/debug directory, which we saw. An additional advantage of using cargo is that command are same no matter which operating system you use, you're working on. So at this point, we no longer provide specific information for Linux and Mac versus Windows. So yeah, that's the pressure of this book. When your project is finally ready to release, you can use cargo build /release --release to compile it with optimizations. This command will create an executable in target/release instead of target/debug. Man, that's a mouthful. The optimization make your Rust code run faster, but turning them on Turning them on lengthens the time it takes your program to compile. This is why there are two profiles, for one for development, one when you want to rebuild quickly and often, and another for building the final program you'll give to user. That won't be rebuilt repeatedly and that will run as fast as possible. If you are benchmarking your code's running time, be sure to run cargo build release and benchmark with executable in target/release. Simple programs, cargo doesn't provide a lot of value over using Rust C, but it will prove its worth as your program become more intricate. With complex project composed of multiple crates, it's much easier to let cargo coordinate the build. Even though Hello Cargo project is simple, it now uses much of real tooling you'd use in rest of your Rust careers. In fact, to work on existing project, you should check out the code using git, change the directory and build. So okay, we are not doing that. Anyways, to read the summary, we can actually, let me just, okay, you're already off to a great start on your Rust journey. In this chapter you have learned to install the latest version, update new version, open locally installed documentation. Did we do that? I don't think we did that. Write and run a program hello world using Rust C directly. Create. Okay, let's try and do let's see, did we do any oh, we have this Rust up doc. Couldn't open browser. The open did not execute successfully. I guess there is some problem in my PC, laptop, Mac, but yeah, you can try running it on your machine and let me know if that works. But you can use Rust docs using that, right? So I'm not going to change my versions right now, but yeah. Okay, let's go to programming a guessing game, chapter 2, programming a guessing game. Okay, and you know what, we'll do this in the next video. Okay, so let's keep it short. We are actually half an hour. Anyways, if you liked it and you want to see more, you know what to do. So yeah, we are really close. Actually, we are not really close to 1,000. So a share would be nice. Anyways, I'll see you next time in the next video where we create this programming a guessing game using Rust. Okay, till then, bye bye, take care, stay safe, and bye.